So in this video, we're going to be talking about operations on functions, but we're specifically going to be talking about the evaluating portion of the operations. So if we were to do f plus g of 4, there's two main methods that we can approach this at, and we'll take a look at both of those main methods in the video. Okay, so the first method we're going to use is calculate the operation and then evaluate it. So that involves us doing the operation of f minus g and then plugging in our -2. So my f of x is 3x minus 7 minus my g of x, which is x squared plus 5x plus 6. So if I go through and simplify this, I'll have to distribute my negative through. 3x minus 7. Don't need the parentheses anymore. Minus x squared minus 5x minus 6. And then combine like terms. No other x squareds. We have 3x minus 5x is negative 2x. And negative 7 minus 6 is negative 13. Now, one mistake people make is that they think this 2 here, since it's in parentheses, they think it means to distribute or multiply everything by 2. However, this 2 represents the same thing as the 2 in this notation does, and that's just means to replace the value of x with 2. So this -2 is what we're going to replace with x, and that's the evaluating portion of this question. So we shall replace x with -2, and then just go through and simplify. Exponents first, so -2 squared is positive 4. My negative sign comes down. We have the -2 times -2 is positive 4. Then my minus 13 will also come down. Positive 4 and -4 will cancel out, leaving me with just negative 13. There we have example 1 for the first method. Okay, in this example, we're going to find the value of f of g of -2, so the composition of f with g using the value of -2. So we're going to use our first method, like we did for the first example, where we find an expression for f of g, and then we evaluate that expression with the -2. So f of g, f open dot g, means f of g of x. So I'm going to go through my outside function. Anywhere I see an x, I'm going to replace it with parentheses. So 3 parentheses minus 7 instead of 3x minus 7. And then the g of x goes inside that set of parentheses, and my g of x is x squared plus 5x plus 6. So this is the setup for f of g of x. Now we just have to simplify this. So distribute my 3 through 3x squared plus 15x plus 18 with my minus 7 coming down. And combining like terms, we have the 18 minus 7, which is 11. So 3x squared plus 15x plus 11. Now we're not actually done. We still have to deal with the -2 here. And this -2 with this notation means to plug in -2. So we are actually looking for the f of g of -2 here. So now that we have an expression for f of g, we're going to use that and replace x with -2. So 3 times -2 squared plus 15 times -2 plus 11, then simplify this expression. So -2 squared is positive 4, and 3 times 4 is 12. 15 times negative 2 is negative 30. Plus 11 comes down. If we go through and finish it off, 12 minus 30 is negative 18, and negative 18 plus 11 is negative 7. Okay, the second method, which we're going to do an example of the basic operations and a composition for, the second method involves evaluating parts and then putting those parts together. So f times g, when we're finding the value of f times g of 3, this means to plug in 3. We could do it the same way we did before and take f of x and g of x and then distribute them out. Those lines were in the wrong places. But that can be sometimes inefficient, especially if you're only finding one value of the expression. So in some cases, it may be better just to find out what the value of f of 3 is and what the value of g of 3 is. Because f times g of 3 is really just another way of saying f of 3 times g of 3. So if we want to find f of 3, we just take 3 and plug in for the f function. So 2 times 3 plus 3. 2 times 3 is 6, plus 3 is 9. And for the g function, it's x minus 5. So 3 minus 5. 3 minus 5 is negative 2. Now if we want to find f times g of 3, then we're going to do 9 times negative 2, because 9 is just f of 3, and negative 2 is g of 3. And 9 times negative 2 gives us negative 18. Okay, in this example, we're going to be defining the value of f composed with g of negative 3 with our two functions f and g off to the side here. Now with this is a composition, so we're going to use the second method for the composition, which looks a little bit differently than the basic operations with the second method. So composition is having f of g of x in normal cases. However, this time we're evaluating, so we're not finding f of g of x, we're finding f of g of negative 3. So, using the second method of evaluating in pieces for composition means that we're going to be starting with the inner piece and working our way outwards. We can't do anything with the negative 3, so that portion is already done. So we'll focus on g of negative 3. So if I do g of negative 3, we replace x with negative 3 in the g equation. And negative 3 minus 5 is negative 8. So I now know that g of negative 3 is negative 8. Let's fix that minus and equal sign. And since I know that, I can now replace it in the overall goal of this problem. So now instead of finding f of g of negative 3, we're trying to find f of negative 8. So I'll go off to the side once more and find f of negative 8. And the f of x function is 2 times x plus 3, with x being negative 8. So 2 times negative 8 plus 3. 2 times negative 8 is negative 16, plus 3 is negative 13. So overall, f of negative 8 is negative 13, which means f of g of negative 3 is negative 13 as well.